Cranes are mechanisms fundamental to modern industry. They may be found in varied forms in many places. All cranes are designed to lift an object and move it from one place to another while the load is suspended. To achieve this, three basic motions are incorporated in the crane mechanism. These three motions are the motion of the hook, the luffing motion and the slewing motion. At one stage of engine development, only one of these motions could be carried out at a time. But now, all three can occur simultaneously. Let's study them closely. Firstly, the motion of the hook, lifting the load. This vertical motion up and down is basic to all cranes. The second motion is known as luffing, which is changing the angle of the jib to allow the crane to either lift the object toward or away from its initial position. The luffing motion changes the effective radius of the jib by rotation about the jib hinge. There are definite limits imposed on the luffing motion. Beyond these limits, the crane becomes unstable. By viewing a protractor scale through his cabin window, the operator can quickly determine the boom angle. As the radius becomes larger, that is, as the load moves further away from the crane, the weight of the boom itself becomes more critical, and the actual load that can be safely lifted is reduced. This can be more easily understood by observation of an overloaded tow truck. When the load exceeds the safe limit at a given radius, the front wheels lift off the ground. To summarize then, each crane has a safe working load for the radius of the luffing motion. There is a maximum and a minimum practical radius at which the crane can operate. The third motion, slewing, is the ability of the crane to move around its own axis. The slewing motion of a crane can be observed on wharves, where the crane can lift loads from the hold of the ship and, by rotating on its own axis, can put the load onto the wharf. The stability of the entire system must be considered very closely when using the slewing motion. Most mobile cranes have outriggers with jacks that enable them to provide a spread of the base for maximum stability. What manufacturing method and material would be used for an outrigger foot? Of course, these outriggers are retracted when the crane is travelling. To summarize, there are three motions of a crane. Although each is controlled independently, they may be operated simultaneously in moving a load from one position to another. The combined effects of the three motions when in operation create complex reactive stresses in the structure. These motions are reflected in the capabilities of modern